Hello everyone! In this video, we are going to learn about inverse functions. What exactly are inverse functions? Two functions are inverse if and only if every domain on one function can be found on the range of the other and vice versa, and their composition is equal to x. To further understand, let us solve some examples that are provided. Starting off simple, we have here our equation, which is f of x is equals to x minus 2. The first thing that we should do is to replace f of x with y. After doing that, we will simply interchange x and y so that instead of y equals x minus 2, it will become x equals y minus 2. Next, we should make sure that the only remaining thing on one side will be the y. In order to do that, we will transpose our negative 2 over 2 beside our x. Don't forget that when transposing, the sign of our number will become the opposite of what it was. So now, we have x plus 2 equals y, or simply y equals x plus 2, whichever works for you. Lastly, let us change y into g to x. And now we have our final answer. If you want to check your answer, there are ways to check if it is correct, which is by applying composition of functions. In this case, we just need to substitute both with the other, as you can see below. If they both have the same result, then you got your answer right. However, if the answer is wrong, then you might want to recheck it. Next, sometimes the given is not always an equation. It can come in the form of a set of ordered pairs, like you can see in our next example, which is a is equal to 16, 4, 9, 3, and 4, 2, in which we all have to do is to simply interchange our x and y coordinates, making that into 4, 16, 3, 9, and 2, 4. And now we have our final answer. The a with an exponent of negative 1 here is what we will use to denote that it is an inverse instead of gx as what we usually use when the given is an equation. Since solving sets of ordered pairs are easy, we have more examples that are equations coming up next. There are times, like here, when the given is already instead of f to x, it's a y. In this case, we can forgo the first step and go directly into interchanging x and y. Again, next, we have to make sure that only our y remains. So first, let us transpose our negative x to the other side, not forgetting to change its sign. Next, in order to get rid of the square beside y, let us square root both sides. And after replacing y with g to x, we now have our final answer. For our fourth example, here we have f to x is equal to 2/3 x plus 5. First again, we replace f to x with y. Interchange x and y. Transpose positive 5 over to the other side, not forgetting to change its sign. Multiply both sides by 3 and divide both sides by 2. Now that we only have y left on one side, we can do the final step, which is to replace y with g to x. For our last example, we have here f to x is equal to the square root of 6x minus 4. Again, first, we replace f to x with y. Next, we interchange x and y. After that, in order for only y to remain on the other side, we will have to get rid of the square root by squaring both sides. After getting rid of the square root, we transpose negative 4 over to x squared, not forgetting to change its sign. Next, we divide both sides with 6 and change y into g to x. And now we have our final answer. Now, as a review of what we've learned today, two functions are inverse if and only if every domain on one function can be found on the range of the other and vice versa, and their composition is equal to x. To find the inverse of a function if the given is an equation, first, we have to replace fx with y. Next, interchange x and y. After, we make sure that only y will remain on one side. And lastly, replace y with gx, denoting it as an inverse. Another thing that we have learned is that in finding the inverse of a function with a set of ordered pairs as the given, simply interchange the coordinates of x and y. Lastly, you can check if the inverse of a function that you have solved is correct by using the composition of functions, which is replacing both of the functions with the other. Thank you for listening, and I hope you've learned a lot today.